break is over. Welcome to the second part of our awesome session today. And Adam Ralph, in particular, is taking over, talking about the last mile of contextual splitting, UI composition, when you bring stuff together. So, yeah, here we go. Adam?
All right, thank you, Alexei. Hi, everyone. So for those of you who don't know me, my name's Adam. I work for a company called Particular Software. We've already talked a bit about N-Service Bus, which is one of our main products. I'm originally from the UK. I live in Switzerland now, and that is Switzerland, not Sweden. So, any North Americans here? Okay. Yeah. So North American fans tend to get the two mixed up. Actually, they do in the UK as well. But all you guys from Norway, it's your neighbouring country. I'm sure you know the difference. By the way, Alex, I'm impressed. Usually when I come to a user group, we're kind of in a classroom or something, a school classroom with kind of a sheet hanging up for the projector screen. You do things differently here, right? Yeah. I think it might be something to do with that conference that's happening tomorrow or something.
Probably, yes.
But anyway, I'm impressed.
I think it's pure coincidence.
So we're going to talk today a little bit about services and composite UI. So there's a lot of guidance out there in terms of when you're breaking your system into different services around messaging and splitting up your service boundaries and things like that. Mainly focused more on the back end. But when it comes to the front end, people kind of say, oh, well, just compose it all together on the front end somehow. Just make a UI which kind of brings data from different services together and you're done. There's very little guidance around how to actually achieve that at a technical level. But at Particular Software, we do a lot for our customers in terms of messaging, but we want to be able to help our customers across the whole stack. We don't want them to be kind of left behind at the UI level. So this is kind of a relatively recent thing that people have started talking about. There is an interesting website called Micro Front Ends, which starts to talk about this kind of thing as well, microfrontends.com, I think. But it's something that's very kind of new in the industry, that people are starting to think about what are the actual patterns we're going to use to put together something which is composed of many services into one front end. So first of all, a little bit about services themselves. So if we look at a kind of traditional design, it might start off something like this. So we talk to our business stakeholders and they say, well, we have customers. Guess what? We are a business, we have some kind of customer. We then sell those customers, well, we sell those customers products, and what happens is they order things from us. So we kind of set up this one-to-many relationship with customers and orders, and then we say, well, we sell many of the same product to the same customer. So we come up with this kind of domain model which relates products to orders in a kind of many-to-many relationship. And things are fairly simple at this point. So I'm sure we've all seen domain models, something like this at some time in our career. But the thing is, things get complicated quickly. So something like Amazon, it is a much more complex page. We have a lot more things going on this page. We have all kinds of things like related products. It's a weird room, because normally I like to kind of point stuff out here, but it's not really going to work so well today. I am going to be showing some code, so I hope some of you guys in the middle between two screens will be able to see it. Is anyone here not familiar with .NET? All familiar with .NET, excellent. So it's kind of. I will be showing some .NET code, but don't worry, I'll try not to make it too scary. So things do grow over time, and functionalities do get more and more complicated. And over time, we can kind of see this kind of thing starting to develop. I've worked with models like this many times in my career. So I've been in teams where we've printed out loads of sheets of A4 and kind of stuck them together with sellotape and put the thing on the wall. I see people smiling. I guess other people have done this who are here. Once we found an A3 printer somewhere in the building, so we had to print out less pages and use less sellotape. But we'd get around this board on the wall, and we'd kind of look at this huge diagram and kind of think, okay, well, where are we going to change this stuff? But it gets tough. It gets really tough to figure out where to make the change. Sometimes you end up having to change the domain model itself and kind of really move things around just to implement some functionality. Because things like SRP, single responsibility principle, where does this live in this diagram? Where do responsibilities end and where do they start? When we're loading an entity here, we have to decide between things like lazy and eager loading. And when we load, a lot of the time you have that kind of massive entity in the middle with kind of 200 fields, which kind of points out to a lot of other tables. So again, I'm seeing a few smiles around. I'm sure people have seen those kind of things happening before. But when we load something through an ORM, for instance, when do we decide whether to load the related entities or not? Do we do it eagerly? Do we wait until we loop through them? It becomes really difficult to make the right choice. So what we try and do with services is we try and follow the coupling. So looking at our traditional layers, so UI, API, business logic, data access layer, database, etc. We try to look within those layers to see what's coupled to what. Now, different parts of these layers will be coupled to each other. So has anyone also worked with systems where you want to add one field and you end up having to add it in the UI layer, in the API layer, in the business logic layer, in the data access logic layer, and eventually in the database? It could be just a Boolean field. So I'm familiar with that too. I've had to do that a few times. So there is natural coupling between these layers, but what we often find is there is often not a lot of coupling between different things within these layers. And what we try and do is look for these kind of vertical slices which can go all the way through, which are less technically bounded, but more capability bounded. So a bit similar to what we heard before about the capabilities, rather than looking at things like layers. And then we need, of course, some kind of service bus in between all of that. But I'm not going to go too deep into that, but we do want some kind of reliable, durable communication between these different layers. Once we've identified that, we try and take these vertical slices apart and form services from them. So there's a bit of UI here, there's a bit of business logic here, there's a bit of data access and database logic here. And then we can start looking at how the UI actually is composed here, because it's all very well drawing this kind of green box at the top here to say that's the UI bit, but how does that fit in with other parts of the UI from other services? So going back to the Amazon example again, I'm not going to try and describe exactly how Amazon is built here. But I am going to use it as an example of a non-trivial domain where we can compose things together using services. Amazon is a non-trivial domain. Does anyone think Amazon is simple? I once had someone tell me that they think Amazon is simple. It's just buying books and selling books and buying books. It can't be that difficult. But I think that's testament to the good job they've done by making something which is very complex in the back end, at the scale they operate, look very simple to the user. Amazon happens to be a very service-oriented company. That's one of the most service-oriented companies in the world. So you can imagine how there may be various services collaborating together somehow to create this kind of page. Now, I've written this sort of controversial or weird sounding thing at the top here. This page does not exist. Obviously, from the user's point of view, it does exist. So you can go to this page on the Amazon website, you can see it, you can see all these product details. So from the user's point of view, it does exist. But there's a way of creating this page where there is no place in the code where you can say, oh, that's the code for this page. If we were doing that, we'd end up with a kind of a God controller. So that kind of long God class which knows about all the different services, and it knows, well, I have to call out to the product catalog now. I have to call out to the related products service, wherever that is, shipping, pricing, etc., etc. Now, the thing is, we don't want code in one service to know about code in another service. Now, if we had that God controller, which service would that sit in? I'll talk about this more a little bit later, but one of the important things about service-oriented architecture is that all code lives in some kind of service. It's not that you have service A, service B, and service C, and other stuff. All code lives within some kind of service. It serves some kind of business capability. So that God controller would also have to live in some service. What does that imply? It implies that one service needs a lot of intimate knowledge of the other services. That's a tight coupling scenario. There's a lot of coupling there between those services. We want loose coupling. So there is a way to code this where what we have instead is kind of a bunch of, you could call them microviews, for want of a better word. And each of these items in our overall view is composed from, let's say, a product catalog for the title and the photo, and marketing with other things and inventory and pricing and shipping. Each of these microviews can somehow inject the information it needs into this page without some kind of God class, some God controller, actually knowing about all of them and having to coordinate that interaction. So let's jump into a bit of code. Let's see how this might work in a composition gateway using ASP.NET Core. So there are various ways you can do this. You could do this kind of composition on the client side in the browser. There are ways of doing that. Or you could do the composition on the server side. So let's have a look at the server side for now. So what we have here is a solution with, it has essentially 3 different services in it and a kind of composition gateway, which I'll go into in a minute. This is the shell project, which contains the dumb infrastructure code for hooking together the more smart things in different services. Now, sales and shipping are very business-aligned services. IT Ops is slightly different. IT Ops is a very kind of technocratic service, and IT Ops deals with kind of infrastructure level concerns. It deals with things like deployments, things like making sure database is available, connection strings, and providing a certain level of infrastructure for the business-aligned services to plug into. So if we go into one of these services, we have a bunch of different stuff. One of them is a sales API host. So this is a web API that the sales service is exposing with its data. So an HTTP endpoint. Then it has some data access layer. And then there is this view model composition project. So I'll come to the events one in a second. In this view model composition project, we have a order details view model appender. It's a bit of a mouthful. And that is the thing that we're going to put into our front end to do the front end work. So what that does is, let's zoom out. The first thing we do is we call this matches method and we give it root data. So this is information about the route that's been requested. So from this we can work out the virtual controller. So that will be the first part of the URL, /orders. And then we'll have this is very kind of basic matching for the purpose of this demo. We say, well, if you're requesting orders and you're supplying an ID, I am interested in this URL. So I can participate in the construction of this page. If that returns true, the infrastructure then calls this append method, and here we pass in this dynamic view model, we pass in some root data, and we pass in the query string. We get the ID from the root, from that part of the URL. We construct a URL using that here, in the last part of the URL, and this is the URL to the sales backend service. So remember, this is the view model appender provided by the sales service, and this is now going to make a call into the sales HTTP endpoint, which is its backend. It then gets a response back. It does a little bit of magic here to convert that into a dynamic object. That's kind of uninteresting infrastructure stuff. And then on the view model, it sets the order number and the order items count using the information that it got from its backend. So I might go through this a little bit quickly at some point. If there's anything that wasn't clear, please do raise your hand and I'll try and explain it again in a better way. So far, so good? Yeah? Okay. And similarly, if we look at the shipping service, we've got a shipping view model composition component that has an order details view model appended as well. It does exactly the same matching here. So it says, if you're requesting orders and an order ID, I'm interested in this URL. I'm going to compose something into it. And it does something very similar. It grabs the ID from the root. It constructs a different URL. This is actually a different port to the last one. This is the URL for its backend service for the, shipping, for the shipping backend service. Makes the call, gets a response, creates a dynamic object from it, and it sets on the view model the things that shipping knows about, which are the shipping status and the shipping courier. Now what we do at runtime is these two view model composition DLLs, the one from sales and the one from shipping, we ship those into the bin folder of the composition gateway. And the composition gateway discovers those at runtime, and it simply receives the URL, it receives the request from the client, and it calls into each of those appenders in a kind of dumb fashion. It just says, well, here's the route that's been requested, here's the dynamic view model, which is a bag for a bunch of properties, and it says, you do what you need to do on the view model in each time. I'll show you how that's wired up in a minute. That's a bit more, that goes a little bit more scary. First of all, let's see it running. Okay, so we've spun up three endpoints. We've got the sales API host here. We've got the shipping API host here. And we've got the composition gateway running here. And if we use something like Postman, because this is not a website, this is the composition gateway itself is still a JSON endpoint. So we can use Postman to query that. And if we, first of all, let's just query the sales endpoint on its own. So here we get the sales, just the information that sales knows about, so the order number and the items count. If we query just the shipping endpoint on its own, we get just the information that shipping knows about. So it knows, again, about an order number, which is the ID of the order, and it knows what the courier is and what the status is. And then if we call the composed endpoint, then we get all that munged into one thing, so one JSON response. Now, in terms of the Wireup, this was created using the empty ASP.NET Core Web API project template. So it's very, very basic, it's very, very low level. It doesn't even do routing for us. So all the routing that MVC does for us, matching a route to a controller and all that stuff, doesn't even do that. So we actually have to set up our own routing. So this, we're going to dive down the rabbit hole a little bit here. So if I do, if something's not clear, please do raise your hand and I'll do my best to explain it. Sure.
If you compose it this way, does it mean that if the view model is actually returning to the client somehow, we are depending on these services to be actually available, and till we get the composition done, we are not able to see anything on the UI.
Correct. So the concern you're raising is that if we're composing this UI in this way, that we're calling, that each backend service is calling out to its own backend service to get that information, each of those services has to be running. Yes, that is correct. Now, there are various failure modes you can engage there. So you could say, well, if one of them is down, I'm going to fail the whole request. Or you could say, if one of them is down, I'm still going to return the partial result that I get back. So in the infrastructure code that calls each of the appenders, it could have some logic in there to say, first of all, you could do it at that level. You could say, well, If any one of them fails, I don't care. I'm just going to return the view model back anyway. And then when you actually render that in a view on the client, you could have some kind of missing placeholders or something like that. That might be okay in some scenarios. In other scenarios, you might want the whole request to fail. So that depends on your business requirements ultimately for what you want your users to see on that page. But then, of course, you could employ any kind of level of caching in each of those services. So you could think about your high availability per service. Something like I don't know. Maybe this is describing Amazon wrongly, but they might care less about the related items than they care about the actual product you're looking at. So maybe if the related items thing wasn't available, they'd still show you the product page. You could still buy that product, and they might have a lesser guarantee of availability around that related items strip of all those items. So it really depends on your business case. So let's have a quick look at Wireup. So if we look at the entry point to the composition gateway, we've got obviously our program.main. This is doing nothing special. This is basically just the template code left as is. If we look at this startup class, so this is this convention in ASP.NET Core. You have this startup with this configure services and configure method. Configure services is a thing that sets up the kind of internal IOC container, this iService collection. So what we do here is this is the bit where we scan our bin folder at runtime for those view model composition assemblies. So in here, we look for anything with view model composition in the name as an assembly. That's then calling this method here with that assembly pattern. We get all the files here which are matching that search pattern. We load we load that assembly, we load all the types, and then we get all the types which are not abstract, okay, and our type of iRoute interceptor. So iRoute interceptor is an interface that communicates that I will intercept a route and take part in UI composition. And then all we do is we just add all of those types into, I'll collect them here in the list, and at the end, we add all of those into our service collection. So at that point, we've set up our IOC container with all those things at runtime. Then in the configure method, this actually tells the app what to do at runtime. So this says, well, when a request is actually made, what should actually happen? What should actually happen in this pipeline? So here we call this thing called run composition gateway with default routes. And there's a bit of kind of boilerplate stuff in here, but what we're saying here essentially is on this application builder, which is an ASP.NET Core thing, we're saying map composable get. So when the template matches this kind of controller ID pattern, the route matches that pattern, we're going to do something special with that. I'll come to that in a second. If we don't match that URL pattern, then we just say, well, just map all other routes to a 404. So it's a basic fallback to a 404. So this is the low level of routing that we have to do when we haven't got something like MVC. In the map composable get, again, there's a bit of kind of boilerplate stuff here. We have this, we pass a template back to this new route thing. Again, these are all ASP.NET Core concepts, part of that API. It's not that important to understand this stuff right now. The interesting part is here in this handle get request. We're saying, we want you to invoke this route handler, and when we get our context, our HTTP context from the ASP.NET Core pipeline, we want you to call this composable route handler handle get request, passing that context to it. And in here, we call yet another class, which is this composition handler. See, I told you we're going down the rabbit hole a bit. It's quite a deep call stack. But each of these kind of responsibilities is kind of quite crisp. In this composition handler, we actually get a result, an actual result to give back to the client. And if that's a 200 OK, for the purpose of the demo, we just assume application JSON, We serialize the result view model into a string, and we write that back into the response. So it's happening. All this stuff is happening at quite a low level. If it's not a 200 OK, we propagate the status code back. So if we get something like a 500 here, then we propagate that back to the client. So let's go into the interesting bit again, which actually handles the request. This is where the most interesting things happen. So here we get the context, we get the root data from it, we create an instance of this dynamic view model object, which is something that we've created. We loop through all the objects which are registered in the container, which are of type iRoot interceptor, where, remember that matches method, where we pass the root into it and we say it's a get method. And for all the interceptors that say, yes, I'm interested in this root, we store them in the list. We can ignore the subscriber stuff in a minute. That's the next part. I'll explain why we have that in the next part. The important thing right now is these view model appenders. So we saw our iView model appenders earlier. Those are the things which actually inject data into the view model. We simply loop through them and we call the append method on every one. Has that more or less made sense? I mean, I know that's quite a deep call stack and there's a lot of code to see there. But essentially what we're doing is we're taking that root, and all this is kind of boilerplate mechanical code so that we can call the append method on each appender with the view model, dynamic view model, and the root data. And the query string if we need it. And then we're actually adding these are all async tasks, so they happen in parallel. We wait for them all to be complete, and we return the view model populated with the data and a 200 OK. If there are no pending tasks, that means we found no appenders, so it's a 404. So let's have a look at that again in a diagrammatic fashion, just so that we've got an idea of exactly how this is laid out. We've got an iView model appender, which inherits from an iRoot interceptor. Now, right now, we don't really need two interfaces. We could have them, so the matches method is on the iRoot interceptor, the append method is on the iView model appender. Right now, for what we've seen so far, they could be on one interface, but I'll explain why we have two in a second. We then have an order details view model appender from shipping, and an order details view model appender from sales. Each of those has their append method called, they inject stuff into the view model, and then we have some Wireup, which actually does that work. So the composition handler is that interesting one at the end, which actually loops through all the types and calls the append methods. And that results in a view model, which goes back to the client in the form of JSON. Now, it's more interesting when we look at this part. So this is the bit which says customers who also bought this item, also bought. These are the related products to the product we're looking at. So this is a list. Now, what we don't want to be doing, again, is writing something which knows about all the different services and kind of loops through them and potentially makes, 6 times however many calls to construct this list. So we can use a very similar mechanism to what we saw before with a slight difference. At this point, we can introduce a client-side message broker. So this is not something like nService bus or RabbitMQ or something like that. This is just a client-side message broker. When I say client, don't immediately think web browser, because in this context, the client could be a web browser. We could be doing this composition in JavaScript, or it could be a composition gateway. So the composition gateway in that context is the client of all the services. So for a message broker, this could be something as simple as .NET events, for instance. This is an in-memory message broker, or maybe some kind of mediator library or something like that. So what we do first is for the URL that's been requested. So again, here it's products. So we're saying products want product, and we want the product with the ID 123. The first thing that happens is that one of the services has to go and find the related products. So we have a view model appender from the product catalog. This is just like the view model appender we saw before. it goes to its backend service and it says, give me all the related products for product 123. That view model appender then raises an event. It puts an event onto the client-side message broker to say, I've found a bunch of products, and and here are the IDs. So it says, for product 123, I found related products 456, 789, etc., etc., etc. So a bunch of IDs in an event. We then have some kind of component from finance and some kind of component from marketing which subscribes to that event. Using the IDs that have been put on that event, it can form a query to its backend, and it can say, give me all the information that I know about for all the products with this bunch of IDs. We can pass those as an array to our backend, as an array of IDs. Each of those components calls into its backend, which could be, again, an HTTP API, something like that. And then, because the components have retrieved all the information they need related to those products, they can start composing that back into the UI. So the component from the product catalog can compose in things like the product name and the image, and finance can fill in the price, marketing can fill in the star ratings, and we've got a composed list. So there, instead of having 4 times 3, 12 calls, we've got, again, the number of calls scales with the number of services. So very similar to the orders, to the single order page we saw before. It's just a different mechanism to do it. And what we end up with in the JSON payload is essentially an array of items where each property of each item in the array has been written into from one of those front-end services, from one of those front-end components from each service. So let's have a quick look at how that works in code. So I skipped over this bit here earlier. Here, we're looking at all the interceptors which are of type I subscribed composition events. And we call on each of those subscribers this subscribe method, passing the view model into it. Now, if we look at the shipping view model composition, we have an orders loaded subscriber. It inherits from I subscribe to composition events, and it does something very similar with the matches method. So this is why we need 2 different interfaces, because the iRoute interceptor has got the matches method on it, and that's relevant to both the iView model appenders and the subscribers. And that's how we go back to here. You see, they're all iRoute interceptors, and we call the matches method on each of them. It's only down here that we start distinguishing between the subscribers and the appenders. The subscribers have a subscribe method, and the appenders have a append method. So looking back at our orders loaded subscriber, it does the same thing in matches. It says, well, when we're requesting orders in a specific ID, I'm interested in this route, I can do something with it. And in the subscribe method, we say, when we get an orders loaded event, we pull all the order IDs, which are the keys of this dictionary on the event, into a CSV, right? Just a comma-separated value string representing those order IDs, or order numbers as we call them here. It then forms a query to its backend service using that CSV of order numbers. It gets that information back into an object, and it loops through it loops through all the shipments that it's received from its backend service. It looks up that order in the orders dictionary by its ID, and for each of those it writes in the shipping status and the shipping courier. So it's composing into every object that's in that array the information that it knows about. So if we run that again, we get our 3 endpoints up, sales, shipping, and the competition gateway. And we can call, so one thing I didn't show you, I'll just show you this quickly. we've got a different appender this time. So if we look at sales, we have an orders list view model appender. So again, this is fairly similar. It's exactly the same in terms of matching. It says when you're requesting a bunch of orders and an order ID, I'm interested, I can compose into this. And it does the usual kind of thing that you'd see in a list retrieval. So it looks for, it sets a page index and a page size. It calls to its backend service to get the list of orders. It then maps those orders to this order view model dictionary. And that's not doing anything too exciting. All it's doing is looping through the orders, creating a smaller view model for every order, setting the order number, setting the order items count. So this is the information that's coming from the sales backend service, and adding those to the dictionary keyed by the order number, which is the identifier for orders. Then this is the important bit. It's raising an event on the view model, and it's passing a orders loaded event with that dictionary set as a property. And then the infrastructure is then making sure that that event is, that delegate that we're registering in the subscriber over here to say when we receive that event, that this whole thing here is actually a delegate. So we're registering this delegate here to be run whenever the orders loaded event is fired. And that is the reason that in the composable, in the composition handler, we subscribe all the subscribers first using the view model, then we call the appenders, so that by the time the appenders do their work, when they raise the event, the subscribers are already subscribed and they get the event. Now, I know that was a lot to take in. Was that more or less clear? Or is there anything in there which is really confusing anyone? Okay, so when we run this, again, we can select just the sales endpoint only, and then we get a list back of orders keyed by their order number and the items count. So that's just the stuff that sales knows about. If we then query the composed endpoint, we get back an array with the stuff we saw before from the sales service and the stuff which has come from the shipping service, the shipping status and the courier. So how's that changed our system layout? So before we had the iView model appender and the iRoute interceptor. Now it's clear why we need the separate interface. We need the iRoute interceptor and the iView model appender and the iSubscribe to composition events. We have a orders loaded subscriber, which is one of these iSubscribe to composition events. We have this new orders list view model appender, which gets the list of ID of related orders for the order we're looking at, and it raises an orders loaded event that is received by the order loaded subscriber, and it composes in the information to each item in the array that it knows about. And then we've got this kind of weird Wireup stuff that we saw before. It's all the weird kind of low-level ASP.NET Core stuff. If, on the other hand, we use an MVC website, if we actually build a website from this, all that kind of weird Wireup stuff gets much simpler, and we can actually reuse pretty much all of this in an ASP.NET MVC website. We just can kind of throw away most of that Wireup stuff and replace it with something very simple. So let's have a quick look at how that looks. So this time round, we've got not a JSON endpoint, but an actual website. So all the code here actually looks identical. It's just this website here which is different. So in here, we've got basic kind of MVC Wireup. So again, this is just the template stuff. The startup looks a bit different. The most interesting things here are the add view model composition. That's actually exactly the same code as we saw before. This is just saying which scans the bin folder for these view model composition assemblies and just puts the type into the container. Then we add MVC, so that's just the basic MVC infrastructure. And then we do something else. We call add view model composition MVC support. So this is the code that we've written. And here we take advantage of MVC composition filters. So we don't have to do that low-level routing anymore. We can just say, when you get a request, invoke this filter, and the filter looks something like this. So it says, now this is one weird hoop that we have to jump through because of the way that ASP.NET MVC is set up. If a route has a view associated with it, the result of the HTTP context is a view result. If the URL does not have a view associated with it, it's a object result. And what that means is that when we want to set the view data onto that result, in the view result case, we have to set view result view data.model, and the object result case, we have to set object result.value. So that's the reason for these two different code paths. It's just a little bit of an annoying thing we have to do because of the difference in what this thing is here and this thing is here. So what this means is we can actually reuse this MVC website as a JSON endpoint and an HTML website if we wanted to. But in this case, we're only interested in the view case because we're only setting up the actual HTML views here. So it's this code path that's going to be invoked. And when we call the composition handler handle get request, it's exactly the same code we've seen before. This is a bit which actually wires up the interceptors, subscribers, and calls the appenders. So if I run that, we should eventually get a website popping up. Ah, okay. Oh, the other one's running. Okay, so stop that. Stop the composition gateway. Run the website again. When it eventually warms up, we get our composited UI. So we got orders with shipment status. When we click into one of those, we get shipping data and we get order data, which is the items count. So again, this is a composed UI working in a very, very similar fashion to what we saw before. So in terms of the objects we've got now, it's basically exactly the same thing as we had before. The only bit that's really changed is this bit over here. So there it is, this bit over here. So if we look back to this diagram, everything looks the same apart from that infrastructure stuff on the left. Just got a lot more simple. So that's how we can do this in a website. MVC is obviously much simpler because it's a higher level abstraction. It does all the routing for us. Now, we can also do this on the client. I don't have a demo of that ready right now, but we could be doing this in JavaScript as well. So we don't have to be doing this on the server side. There's not just one place where we can do UI composition. Now, whether you do it on the server side like this, or whether you do it on the client side in the browser, really depends on, I guess, how many services you've got, what kind of caching strategies you can provide. Because here, if we're using something like a composition gateway, we request one URL from the website, from the HTTP endpoint. That and its backend goes out to several others and gets the data for us and returns one big payload. Now, that payload might be big, it might be small. If we were doing it on the client side, we'd have to make several calls from the browser out to the various backend websites, backend HTTP endpoints. So we'd have many requests coming from the browser. But on the other hand, some of that might be highly cacheable. So some of the stuff might be cacheable for a month or a day. So you can take advantage of caching strategies to actually make that much more efficient. So that really depends on the structure of your page and the data you're showing on it. So for now, I keep mentioning services, and I keep mentioning that we've got these front-end components coming out of services being composed into this UI. So it kind of starts to beg the question of what a service is, because a lot of the literature you might read, especially around microservices, says that a service is a running process. But here we've seen that a service is a little bit more than that, because, for instance, a sales service had a sales HTTP endpoint running in the back end, and it was building an assembly which we were shipping into the composition gateway at runtime and doing some work there. So first of all, what a service is not. So a service is something that only has functionality, like a calculation thing or a validation thing. That's not a service, it's just a function, something that's just a pure functionality of that type. Something that is just a database, so something that really only exposes kind of create, read, update, delete semantics on data. That's not a service either, it's just a database. And this is one really important point. If you put a web API on top of a database, it does not suddenly make it a service. That is not some kind of magic dust that you sprinkle on a database and say, hey, we've got services. That doesn't actually change the fact that it's a database. It's just a database with an HTTP entry point instead of a SQL client entry point or something like that. A service, rather, is the technical authority for a specific business capability. And you might ask, are these the same capabilities that Nick was talking about earlier? And to be honest, I don't know, because I don't know enough about the use cases. So the things we saw earlier about business capabilities versus different ad providers, or Facebook, Twitter, and LinkedIn, or whatever it was, I don't know enough about the use cases yet to say whether those are our business capabilities or whether something else is our business capabilities. These things come out of looking at use cases. But some of the important high-level rules around services are that all data and business rules reside within the service. Or you might think of this as a service boundary or bounded context in some of the DDD literature. And really importantly, I mentioned this earlier, when you're defining your service boundaries, nothing is left over. So, as I said, you don't have one service, another service, and other kind of bits of stuff, because that actually stops you from asking the hard questions about what belongs in each service. It's kind of an escape hatch, like a get-out-of-jail-free card. So all capabilities, all code ultimately must be serving some kind of business capability, otherwise it shouldn't exist, right? We don't just write code for fun. Maybe unless our project's failing, we know it's going to fail and we're going there Rust or something. But otherwise, most of the time we should be writing code which serves some kind of business capability. That's what we're paid to do. So the implication then is that every single bit of code, if a service is a technical authority for business capabilities, that piece of code must exist from within some kind of service. And when we look at systems versus services, this is playing into a bit more about what we've seen so far. Systems are very different to services. So we might have a system which is a mobile app. So we've got up here an Objective-C app running on an iPhone. We've got here a back-end .NET app, maybe running an ASP.NET Core. We've got a Java portal running on whatever the flavor of that is in Java. And it's tempting sometimes to think of these as our services. This is something that Nick showed earlier on. But our services cut across these things. They are the vertical slices through these things. The implication of this is that part of service 1 might be an Objective-C component. Part of service 1 might be a back-end component. And another part of it might be a Java component. So there's a many-to-many relationship between systems and services. A service can consist of components a system consists of components from many services. A service may have components running in many systems. It's almost like when you're playing with Lego, and you start off with that kind of green board, and if you're a little bit obsessive like I was when I was a kid, you'd have all your bricks in different coloured piles. That's what I used to do. So if we think of those piles as our different services, in order to build a system on that green board, you can think of the green board as, say, that composition gateway shell. We pick bricks from each service, and we put that onto the green board and build a house, and that's our system, and that's what we ship. So that's what we were doing earlier. We were building view model composition components from each logical service and deploying them into a composition gateway. Systems are physical design. Systems are physical runtime deployment concerns, whereas services are logical design time business concerns. Services are built around business boundaries, whereas systems are built around logical deployment technical boundaries. And that's one of the things that that I found very difficult to get my head around when I first started thinking about things in this way. There is a lot of conflation between services and systems in the industry. So people think of services as, for example, an HTTP endpoint. And when you think of your services that way, you're constraining yourselves to physical concerns. Whereas if you look at how your services can be organized, it's around business boundaries. And once you release yourself from the conflation of the physical with the logical, it allows you to do this kind of thing. Now, each of those components that we saw earlier was making a call to its backend service over HTTP. Now, especially when we're in a server-side scenario, like we saw just now, one of those components could choose to go straight to the database. Because once the infrastructure level, once that green Lego board is called into the appender, we're already inside the code of the shipping service. So that code from that shipping service has all right to go straight to its database directly. It doesn't have to go via an HTTP API that it's exposed. And in that way, the data from the service does not leak out because we're already calling code from that service, and that code can look at its own private data. So in that way, we still get the encapsulation at runtime. Am I still within time, or we're getting to the end now?
Yeah, I'm a little bit forward.
Okay, so in that case, that's a good time to ask. Does anyone else have some questions before we wrap up?
I mean, I think it brings complications in terms of that the service team needs to be composed of specialists with a lot of different system team, right? We do a service team. As soon as we start assembling a system, we do that conflict of interest because they will need to operate within the service and at the same time building a system like mobile app that needs to be expert in many services, and then brings a lot of context switching. Right.
Okay, so your concern is that you're going to have to build a system at the same time and you have to context switch into a service. Yeah. Right, so this is going to a little bit about team structure now. So so the IT ops service that I described, which is this kind of technocratic service which deals with infrastructure and kind of Wireup, that team ultimately has to have new requirements have to go via that team somehow. Now, it's not saying that that team has to be kind of some godlike power that knows about all the services and all the details of the services, but it has to at least know what services exist. And then each service team has to have obviously knowledge of its business capability, and they're the people that really know about the business. So from a business point of view, the IT ops people are dumb. From the business point of view, that's not a very nice word to use. But these are the people that are the real infrastructure and code and kind of technical experts around deployments and building a mobile app and actually shipping it into the App Store. But the actual business capabilities within the app, they kind of don't really know anything about it. All they do is make sure that the right service is shipping the right components, and they kind of just call them and say, do your work. So if you've got a small team, if you don't have many developers, what you're going to end up doing is wearing different hats. So you might have to have an IT ops hat on, and then you might have to swap to your kind of sales hat and think, you know, okay, how do things work in this context? That requires a lot more discipline. And if you've got larger teams, you can start to actually put people into service-specific teams and IT ops teams. Does that more or less answer your question?
Yeah.
You had a question down here?
Yeah, I was wondering about the composition UI engine that you built. Because like in Amazon, you obviously have this specified layer. But I think when you're going over different micro functions and trying to stitch that together, you're just generating one HTML page basically.
Right.
And in real world, you actually have to know which order those HTML elements are.
Right. Okay. Okay. So you're talking about the overall layout of the actual HTML. Okay. So one thing I didn't show you actually was. Does anyone mind if we keep going for a few minutes? Okay. So one thing I didn't show you was the actual view. So if we look at say orders, order details, we actually do have an HTML view here. So this is a thing that is actually picking stuff off this view model that's been passed from the back end and is actually rendering them into the page. Now, there's another service which I didn't talk about. There is these two kind of special services, which are the IT ops service, which is a technocratic thing, and there's another thing called the branding service. Now, ultimately, you want a team in your organization to be looking at things like, for Facebook, having the right Facebook blue, making sure the Amazon site is that kind of orange and black kind of thing, or the Yahoo purple, which no one really cares about. And actually, those kind of people would actually be quite happy that they're recognised as a first-class service within the organisation, that they're not kind of just tacked on at the end somewhere. So they are ultimately the people which are responsible for defining this layout. So, and again, they don't really know where shipping status and shipping courier is coming from. They don't really know anything about the business rules behind it, but they know how it should look. So they know that the price should be displayed in this way and the shipping details should be displayed in this way. So they will define the HTML view and a bunch of CSS and a bunch of decorating JavaScript around it. If you look at the micro front end site that I mentioned, microfrontends.com, they're looking at a slightly different approach where each service actually composes in HTML, which is also interesting. I'm not entirely convinced about that yet. At the moment, I'd rather concentrate on kind of just dumb object model, which is just ultimately a JSON payload, because then I think the writing of HTML requires a little bit too much knowledge of those services in terms of the actual physical layout itself, because the branding team might want to have divs in certain places for layout purposes, and then all of a sudden that gets pushed into the services. So I think it might be leaking a bit too much of that in there. But then again, I'm not sure if in their approach they're being so strict about what belongs in a vertical slice and what doesn't, and whether components really belong to those services or not. Does that more or less answer the question?
Yeah. I just know from another talk earlier, not that this, another thing, that one of the Norwegian companies doing something similar. What they are doing is basically what you said now. They are just calling a lot of backends, or micro front end backends, or whatever you want to call them, and then they get render HTML from all those different micro front ends,
Right.
And then they basically have this master template, or whatever you want to call it, on the front end, like for instance for order. Basically what it says is just shipping details, recommendations, just the order of stuff.
Right.
And then it's just stitching in everything it gets from all the different services. In addition, they do some complex logic about all the dependencies like JavaScript and CSS and stuff like that.
Okay.
Basically just compiling it together, de-zipping them, and do a lot of stuff with those kind of things.
Right.
And then they're monitoring those files to see if they exceed their size or something like that.
Ah, okay, yeah. So I think everyone's kind of working out where to draw those lines right now, because this is a kind of it's something that hasn't matured yet, and it's something that we as a particular software, this is an area of concern for us now, but we haven't built a product around this as of now. We're kind of starting to think about something that we could do, but it's very early, kind of just bouncing ideas around right now. This code is kind of there is a kind of mini framework in here that you could pull out. This is actually this whole talk this evening is actually extracted from the workshop that I've just done with NDC, which is why it was just like one part of the first module, so which is why I had no idea how long it was going to take, but it seemed to have gotten to the end, which is good. But yeah, I think it's an interesting space, and it'll be interesting to see what develops in it, because I do think it is that kind of last missing part of the whole service stuff, which sounds great otherwise, but how do you write the front end? So I guess we should probably finish up. Getting a little bit late now. So if you want, so I've talked a lot about. Well, if you've got another few minutes, I can talk about one more thing. If people want to stay around for a bit.
Just Jimmy wants you back.
Pardon?
Jimmy wants you back.
Jimmy's at Geek Beer. Jimmy's
Yeah,
at
I
Geek
know.
Beer. Yeah. Oh, is he twittering me?
Me saying let you go.
Okay. You can wait. Okay, so you might be thinking, so we've dealt with the query side, but sometimes, for instance, you say when you book a hotel room, you have to fill in your name and details and your credit card details at the same time, and then you hit go. Now you can imagine that those things might be the responsibility of different services in the back end. So how do we then do this thing the other way round on a kind of HTTP post? So I have a solution to that, which we're also trying out in some other demos. Now, if we look at one of the view model appenders, let's say one of the simpler ones, like the order details in, where are we, sales. So what if I change this to iHandler instead of view model appender, and I change this to, I don't know, foo handler, and I change that this can stay at matches, and I change this to is post, right? So now it's going to say when you're posting something to this URL, I'm going to do some work, and instead of append, I just call this something more generic like handle, and instead of new view model necessarily, I could call it again something a bit more generic like body. We can actually use exactly the same mechanism right now, because the pipeline would be getting an HTTP post in for a certain URL. It would look for all its handlers, and it would grab the body of the post into some object here, which we're calling body, and it would call into each of these handlers to say, here's the body, you do something. And instead of forming a GET request to its backend API here, we could pull out things from that body, we could pull out properties from that body, and we could put a message on a service bus to the back end to do some work. So you can see how now this can work the other way. It can go from UI composition to form a query to kind of UI decomposition, to take an HTTP post and actually decompose that into various back-end calls to different services with data. And it's at that kind of point you'd want to introduce something like a message queue, because you want those messages to be durable. When we had the client-side message broker, kind of doesn't really matter if the events get lost, because that probably just means that the browser's been closed or something. But if someone posts their data to the backend server with their credit card details and their address details, you want to take their money. Right? So you decompose that post body into various requests, and you put a message on a durable message bus in order to actually charge the credit card. Does that make sense? Okay, so I've talked a lot about service boundaries. If you're interested in how to actually find service boundaries, I'll be talking about that on Thursday at the conference. I think it's the very last talk on Thursday. I think it's from room 7. So if you want to see, and there I'll be actually showing a back-end workflow. So what actually happens when you go through this back-end workflow and you do actually compose data, and how that can be handled in the back-end, and how to start looking at a domain and saying, well, what are our services in this big mess? So if you're interested, then we'll be coming on to that. So I hope that's been of some use. I've enjoyed it very much. I hope you have too. So thank you very much.